Manual summarization can be configured anywhere in the network. This is a feature unique to all the routing protocols that we will study. For example, in OSPF, manual summarization is configured only at area boundaries. Click the Command button to view the command. The router where manual summarization is configured is called the summarizing router. The summarizing router's routing table contains the summary route and the component routes. The summarizing router advertises only the summary route with a default administrative distance of 5. Therefore, the next hop router has an AD of 5 for that route. All the routers more hops away use the default of 90, or the value configured on the router. We will continue our discussion on manual summarization in the next slide. Manual summarization works as follows. The summarizing router adds a route to its own routing table for the summary prefix and prefix length. The outgoing interface is set to null 0. This is called a discard route because a packet with a destination with the longest prefix matched to a discard route is dropped. The discard route does not appear on the other routers, only on the summarizing router. If a summary address is configured on an up interface, the neighbor adjacency is reset. This is not desirable on a production router. Click the Command button to see the messages that are issued. Let us now discuss the advantages and disadvantages of manual summarization. The advantage of manual summarization is that it decreases the size of the routing tables of subsequent routers, although not that of the summarizing router. A disadvantage is that it can cause suboptimal routing. Packets routed to inaccessible destinations will be routed to the summarizing router before being discarded. A summary route is only removed from the routing table if all its component routes are removed. This is what causes the suboptimal routing. Click the button to view the example. Router B has networks 192.168.1.0/25 and 192.168.1.128/25 and a summary route 192.168.1.0/24. Suppose 192.168.1.0/25 fails. The summary route is not removed because 192.168.1.128/25 is still up. So packets addressed to 192.168.1.0/25 will still go to router B. Once at router B, the packet now only matches the summary route, which goes to null 0. Let us talk about the bandwidth percent command. EIGRP has a command to limit the bandwidth that it uses for processing. This prevents EIGRP traffic from crowding out data traffic. First, check the bandwidth on the interface with the Show Interface command. Then configure the bandwidth percent command. EIGRP uses up to the percent of bandwidth configured. By default, EIGRP uses up to 50%. The commands must match on both sides of the link. Use the Show Run command to verify. Let us look at an example. There are 3 frame relay PVCs on a multi-point interface with bandwidth 300 and IP bandwidth percent EIGRP 120. EIGRP bandwidth would be 60 kilobits per second, or 20% of 300 kilobits per second. The next slide deals with the concept of hello interval and hold time. Hello messages are sent at certain intervals to keep in touch with the neighbor and check that the link is up. The hello interval defaults to 5 seconds. The default hold time is 3 times the hello interval. If a neighbor does not receive a hello in the hold time, it assumes that the link is down and the neighborship ends. The default values can be modified with the commands shown on the screen. Hello interval applies to the local router. Hold time applies to its neighbors. For example, if the commands are configured on R1's FA0/0 interface, hellos will be sent out to the FA0/0 interface according to the hello interval. Neighbor routers attached to the FA0/0 interface will wait the configured hold time before assuming the interface is down. For neighbor adjacency, hello interval and hold time do not have to match on both sides of the link as they do in OSPF. Now, let us look at split horizon. When split horizon is enabled on an interface, no updates or query packets are sent out of an interface through which that packet came. This reduces the possibility of routing loops. For example, in the figure, if RTR1 learns about the route 25.25.25.0/30 from RTR3, then any updates or queries concerning that route will not be sent out F0/1. We will continue our discussion on split horizon in the next slide. By default, EIGRP split horizon is enabled on most interfaces, except frame relay multipoint interfaces. Use the command on the slide to disable or enable split horizon. In the next slide, we will discuss stuck inactive. A route enters the active state if it fails and there are no feasible successors. This means it is actively seeking a way to get to the destination by running dual. Since query packets can be sent to routers many levels down, it can take a long time to get a reply. If all the replies are received before the active time timer expires, then the route becomes passive. However, if there are outstanding replies, dual declares the route as stuck inactive, SIA. The connection is also reset. SIA query and SIA reply are two EIGRP message types for iOS 12.1, 5, and later. They facilitate the active process enhancement feature that helps to keep the router-neighbor relationship from being reset. This is important on production networks. It is desirable to limit the query scope so that stuck inactive does not occur as often. Let us see how to limit query scope in the next slide. To restrict query scope, use passive interfaces and stub routing. Route summarization also helps to limit query scope because a router responds to a query if it has a matching summary route, even if it does not have an exact matching route. In addition, the query stops there. It is not propagated to the router's neighbors. Now let us discuss load balancing.